Hello everyone, this is Sumit Tantri, currently a third year computer science engineering student at RV College of Engineering. So, our project title is Stock Prediction using Deep Learning Techniques. So, let us first understand what are the things involved in deep learning. So, first one is neural networks. So, neural networks are a type of machine learning model inspired by the structure and function of the human brain. So deep learning basically consists of three layers. The input layer is the first layer where data is fed into the model. Each neuron in this layer represents a feature of the input data. Then comes the hidden layer, which is the layer between the input and the output layer. Then comes the output layer, which is the final layer which produces the output of the network. So also weights and biases are involved in deep learning. Weights are basically parameters that adjust the strength of the connection between neurons. So and biases are additional parameters that help the network make better predictions by shifting the activation function. So the first term which we can see in this website is the learning rate, which is set to 0.01. So which determines the size of the steps that the model takes towards minimizing the loss function, which measures how far the model's predictions are far away from the actual values. So during training, the model adjusts its internal parameters, which are weights and biases respectively. So next is the input dropout rate, which is a regularization technique where a fraction of the input units are randomly dropped during training to prevent overfitting. Then output dropout rate is similar to the input dropout rate but applied to the output units. So timestamp per training refers to how many previous time steps the model looks at when making a prediction, which we have set to 5 in this case. And size layer defines the number of units in each layer of the neural network, which defines the complexity of the neural networks, which we have defined to 32 here. So training iteration is the number of times the model will cycle through the training data set to 10 here, and future days to forecast is set to 30, which sets how many days into the future the model will predict stock prices. And smoothing weights is set to zero point 0.5, which is used for smoothing the output predictions, which helps in reducing volatility and making the predictions more stable. So initially the money is set to 10,000 US dollars, and maximum units which we can buy are 5, maximum units which we can sell are 10.
I am Srinidhi. As already mentioned, in this project of stock market prediction, we have made use of deep learning techniques. In particular, we have made use of two deep learning architectures, LSTM and GRU. First, let us look at LSTM. LSTM stands for Long Short-Term Memory. LSTMs are a type of artificial neural network, a subset of what's called as recurrent neural networks or simply RNNs. But RNNs face a significant challenge, that is they struggle with learning long-term dependencies in sequences due to a problem known as vanishing gradient. This is where LSTMs comes into play. The magic of LSTMs lies in their unique complex structures, which include memory cells and three types of gates, namely the input gate, the output gate, and the forget gate. These gates control the flow of information, telling what should be remembered, what should be forgotten, and what part of memory should be used for the current output. This architecture allows LSTM to maintain information over time, effectively handling long-term dependencies. To summarize, LSTM has four major components: the memory cells, which are the core part of LSTM units. They store information over time, acting as short-term memory. The next is the input gate. This gate controls what part of input memory should be added to the memory cell. The next is the forget gate. As the name suggests, this gate decides what part of information should be discarded from the memory. Finally, the output gate determines what part of memory should be used to calculate the final output. Now, coming to the relevance of LSTM in stock market prediction, as I already told, LSTMs are a special type of RNN designed to learn from sequences of data, making them particularly useful for series forecasting, such as predicting stock prices. In the context of stock markets, predicting future price is particularly challenging because of high volatility, influence of various factors such as geopolitical events, economic indicators, and market sentiments. LSTMs helps address this complexity by analyzing the historical stock prices and trends, capturing patterns over the time. and might indicate future movements. For instance, feeding an LSTM network with historical stock price, it can learn the underlying patterns and potentially predict future prices or trends. We have exploited the same advantage in our project as well, where we present the deep learning model with the historical price data. The input provided gets trained in the backend and outputs the final prediction and recommendations.
I am Tanmay Aslal, currently pursuing third year in computer science at RV College of Engineering. Our project dataset have been trained on 18 models which are mainly based on GRU and LSTMs. So first let us know what is GRU. GRU, also known as Gated Recurrent Unit, is a type of recurrent neural network architecture that is particularly effective for time series data, such as stock market prediction. GRUs are designed to handle the problem of vanishing gradients in standard RNNs, making them more efficient in capturing long-term dependencies in sequential data. The key concepts of GRU are gates and hidden states. There are two types of gates, update gate and the reset gate. The update gate decides how much of the previous information needs to be passed along to the future. It controls the flow of information from the previous hidden state to the current hidden state. The reset gate determines how much of the past information should be forgotten. It controls the influence of the previous hidden state on the current hidden state. Hidden state. Hidden state in a GRU serves as the memory that carries information through time. It gets updated every time step based on the current input and the previous hidden state. Now let's see how GRU works in stock market prediction. GRU consists of three layers: input layer, GRU layer, and output layer. In input layer, historical stock market data such as the daily prices, volume, etc. is fed into the network with each time step representing a specific interval. The GRU layer processes the input sequentially using the update and the reset gates to manage information flow, capturing both short-term and long-term trends in the data. In the output layer, the final hidden state, which summarizes the entire sequence, is used to predict future stock price or trends. The advantages of the GRU in the stock market prediction. GRU is very efficient. GRUs have fewer parameters compared to other RNN variants like LSTMs, which makes them faster to train and less prone to overfitting, especially with the smaller datasets. They are good at memory handling. GRUs effectively capture long term dependencies, which are critical in stock market prediction, where past events can influence the future prices. They are simpler than LSTMs, with only two gates, that is, the update gate and the reset gate, instead of the three gates, which makes them easier to implement and tune.
Hello, I am Vinay Kargi. So, after learning about the fundamental terms about the neural networks and how it works, let's look into execution and the output of the model. So here the model takes a CSV file, so let's upload a CSV file. The CSV file contains the following data, where the date, open opening cost of the stock, high the day high cost of the stock, low close and adjacent close, and the volume of the stocks of that company are given for each day, and this model is being given as an input. So let's train the data. Yes, here we can see it's undergoing the training process. So by the time it trains, let's look into a few more terms. So here we can see stock, MA5, MA10, MA20, MA30, and predicted close. Stock actually it suggests the buy and sell strategies by the predicted graph given by the trained model. MA5 is the average of past 5 closing prices. Similarly, MA10 is the average of past 10, and MA20 is average of past 20 close prices, and MA30 is average of past 30 close prices, and the predicted close is the predicted line graph by the neural network model. So yes, we can see that the model is trained. It runs for 10 epochs, that is, it undergoes 10 iterations. And so yeah, now let's have a look have a look into the graph. So we can see the model suggests the points where a person can buy and sell, and consequently make profit out of this. So this model suggests the buy sell strategies for 1 year, and yeah, this is, so you can see whenever the model finds a local minima, it suggests to buy the stock, and whenever it looks into a local maxima, it suggests to sell the stock. But yeah, there can be some few discrepancies where the buy price is high and sell price is low. That is because the model looks into the local minima and maxima, not the global ones. So how the stock price is going to behave ahead in the future, it has no idea about that, but yeah, locally it works fine. So this was about the graph. Now let's look into the histogram. The blue bars represent the real price of the stock, and the red bars represent the predicted price of the stock. As you can see, they go hand in hand, and there's not very much difference between these two. So yeah, uh, that is the credibility of the neural network model, and it shows that it is working fine with very minimum losses. And you can also see the loss graph. As the number of iteration increases, at a certain point the loss shoots up high, but consequently as you reach the end of iterations, it becomes low and low, and finally reaches the lowest point. And so you can say that 10 epochs, or any number greater than 10, will decrease the loss further. Yes, after looking into the graphs and stats, we have a simulation log wherein it suggests, it gives a complete strategy for 1 year where you can buy, sell. It also handles the balance amount and what amount are you left with at the end of the year. So suppose that on this date you buy 5 units at a price of 605, and your balance left is 9394. Initial investment amount is 10,000. So yeah, and after a few days you sell those 5 units and make a profit of 631, and your inventory will be increased to 10,025. So this is your balance after the first investment. So yeah, further when you make investments throughout the year, in the end you will be left with this amount, which is at loss currently. So it's not that one person cannot make profit out of this stock, but yeah, as prescribed by the model, currently the stock is under loss. So the investment is minus 6.7%. That is approx around, you will lose around 678 rupees after investing 10,000, and the overall gain, that is minus 678, that is 678 rupees lost. Yes, so this was all about the model and its results. Thank you.